So, hello everyone, my name is Ishant Kumar, and today we are going to solve another problem which is going to be Alice and Bob. It is a greedy implementation problem. It is currently 900 rated on Codeforces. So, let's read the problem. Alice and Bob has a bag with n marbles with the integers vi written on the ith marble. They play the following game. First, each player chooses an integer. Let's denote the integer chosen by Alice as A and integer chosen by Bob as B. After that, they start drawing marbles from the bag in any order until the bag is empty. Okay. For each ball, the point goes to the one whose chosen integer is closer to the integer on the marble. In a case of a tie, Alice gets the point. Okay. And here are some examples for marble integers. uh, 10, 1, 7, 18, 20, and many others. So Alice has chosen 10 and Bob has chosen 30. So note that she will get point for the marble 20. So Bob will get and Alice gets the point. Note 1, 2, 3. Yeah, so Bob has chosen the highest integer. He will get only 1 point for this, but let's talk about it in a bit. Bob has managed to find out in advance which integer Alice will choose. Help him to choose his integer in such a way as to maximize the number of points we receive. Let's look at the input that we will be getting. The first line contains in t single integer t, the number of test cases. Okay. Then each test case consists of two lines. The first line contains two integers n and a. N will be the number of marbles and a will be the integer chosen by Alice. Since Bob has somehow got to know what Alice will choose, that's our advantage point, and that's how we have to manipulate the game and keep it on on Bob's side so that Bob will win. The number of marbles in the bag and the number of chosen by Alice. The second line contains n integers v1, v2, vn, which is going to be the values of the marble. Uh, Additional constant on the input, the sum of n across all there does not exceed 3 into 10 raised to 5. So as an output, we have to give a number b. B is the chosen number of Bob. We have to help Bob choose his number so that in all the cases, Bob gets a victory over Alice. So let's see what the problem is trying to say. So in the question, n is the number of marbles. A will be the Alice choice, the integer chosen by Alice, and B will be the integer chosen by Bob, which we have to select. Point goes to the one who's chosen closer to the integer. So the marble, the number of the integer written on the marble which comes out from the bag. Whoever's chosen integer is closest to that marble, the point will be given to them. And if it's a tie, the point will be given to Alice. It's written here actually. In case of a tie, Alice gets the point. So let's move on next. Bob knows Alice's choice. This is going to be the game changer since we already know the integer that Alice is going to choose. So we have an advantage in choosing Bob's integer. So let's see what number should Bob pick. So for this, let's take the first test case here. So this is the first test case. So for in here, let's do it like this. This is n and this is a. So and in this first test case, n will be the number of marbles, which is going to 7, and a is the number chosen by Alice. So in this case, Alice has chosen 21. So in this problem, it is not guaranteed, it is not fixed. The value of b, the number of integer that Bob can choose. It is not fixed. Any number can be chosen from our side. We can give any output until and unless it maximizes the number of points Bob receives. It means in all the cases Bob should win. We have to choose that number. It is not constant. What number should we pick for Bob? So in the first case, let's analyze what number should we pick so that Bob can win. Bob can get the maximum point. So Alice has chosen 21. So in here there are total 7 numbers. So to win, in here, since Alice has chosen 21, the first two numbers are closer to it. So 2 points will be given to Alice. And let's say we have to score more than 3 because there are 7 numbers. If we break down, let's say Alice gets 3 points and we get 4 points. So we'll win in that case. And to get 4 points, we have to choose a number. If we choose a number between 20 to 30, it will be still closer to 21, so Alice will get the point. And if we choose a number between 40 to 50, it will be yeah, so up to 40, Alice will get the point. So 4 point will be occupied by Alice, and even if we choose between these two, Bob will lose because we'll be getting only 3 points. So we have to choose a number between 30 to 40 in order to get the maximum point, which is let's say we choose 31. So for 31, let's say Alice has chosen 21, so we'll get these 2 points. But for 31 from here, our number will be close, so this point will be ours, this point will be ours, and all the 5 points will be ours. So we'll get a victory by 5-2. So let's look at the second test case. So in the second test case, Alice has chosen 500 and 500, let's say. So up to 600, he'll get the point. And there are 6 numbers. So we either have to get uh, 4 to 4 and 2. The point should be 4 and 2 in order to get our victory. But I don't think it will happen in this because if we choose between these two, Alice will still get 3 points. He'll be able to get these 3 points. If we chose between these two, 300 and 500, Alice will still get these 3 points, and these will be getting only these 3 points. So yeah, it will be a tie in this case. And let's move on to the yeah, it will be a tie. Let's move on to the third case. Here Alice has chosen the exact number written on the integer. There are two marbles, both of number 7. So no matter what number we choose, Alice will still get the point and will attain the victory. So our goal is not to make Bob win every match, since we are already cheating. Our goal is to maximize the number of chances of Bob's victory. So keeping that in mind, we have only 3 cases. Keeping that in mind, what numbers shall we choose? Because the output is not fixed. There is a lot of numbers we can choose from. Like also between 30 to 40, there is a lot of number. Between 300 and 500, there is a lot of numbers we can choose from. So how do we fix that number? So in order to fix that number, we can do one thing. Let's say that Alice has chosen 21, right? So we compare Alice's number to all the number of marbles, integers that are of marble, and check how many how many integers uh, are higher or are lower than Alice's choice. Meaning, let's take this first test case. Let's take this 21 and compare this 21 to all these numbers, and Let's see how many integers in the array is higher to the choice of Alice and lower to the choice of Alice. Let's see. So let's compare to 21. This will be lower. 20, this will also be lower. So there are two lower numbers. Let's write it. Lower will be 2. Next, let's check how many numbers are higher than Alice's integer. So Alice's integer's higher number will be this one, 30, 1, 2, 3, 4, and 5. So total number of 5. There will be 5 numbers which are greater than Alice's choice. So what we can do is, yes. So we can check in all the test cases that how many numbers are higher than Alice's choice and how many numbers are lower than Alice's choice. What that will help us in is that let's say for this test case we have a number of uh, higher integers than Alice's choice is greater than the lower ones. So what we'll do is we'll choose a number higher higher than Alice's choice. We can choose any number higher than Alice's choice and we'll get all these 5 points. Let's say if we choose 22, let's say if Bob's choice we choose 22, it will be closer to 20 as compared to Alice's number. It will be closer to 30, 40, 50, 60, 70 and all. It will be closer to all the numbers since the higher number is greater in this test case. For let's say for some test case, it is quite the opposite. The lower count is greater than the higher count. And let's say Alice's choice is somewhere around 40 and the lower count is greater than higher count. So let's actually take a test case. 1, 2, 3, 4. There will be total 7 numbers. 1, 2, 3, 4. Then let's take 15, 17, and let's take one more number which is going to be 5. Yeah, so in this test case, 1, 2, 3, 4, and 5. These 5 numbers are lower than Alice's choice, and these two numbers are higher than Alice's choice. It means the higher number is 2 and the lower numbers are 5. So in this test case, we have to choose a number just lower than Alice's number so that we'll get this 5 point. Instead, since we have to maximize the number of percentage of winning for Bob, we'll choose this lower number and we'll choose a number lower than 14. Let's say we choose 13. So what will happen? We'll get this point. All the lower points will be R. It means we'll get a 5 point, and Alice will get 2 points, and we'll win eventually. So what we can observe from this, let's say if in some test case the higher count is greater than lower count. So in that case, our choice will be one more than Alice's choice. And let's say if in some test case lower count is greater than higher count, then Bob's choice will be one less than Alice's choice. So in that case, as we have seen here, we can if we choose 13, which is just one lower than Alice's point 14, we'll get all the 5 points, and Alice will end up with only 2 points and will win. So this is all the logic for this problem. Let's see the code. So let's see it from here, from int main. I've taken here t, which is going to be the number of test cases. Uh, so on the first test case, I've taken n, which is going to be the number of marbles. A, Alice's choice, and B will be Bob's choice that we'll give. And yeah, so as an input, we have given n number of marbles and Alice's choice and all the numbers written on the marble. This is the input that we have given in the problem. So let's see the exact logic that we have done here. So I've taken lower count and higher count. I've started an iteration and I'm comparing Alice's point, which is A, to all the points inside the vector, which means I'm comparing Alice's point to all the points, all the integers written on the marble. If Alice's point is greater, uh, if Alice's point is greater than if Alice's point is greater than the integer written on it, will increment the lower count, and if the number integer is greater than Alice's point, will increment the higher count, and at last that uh, we'll compare this, right, actually, that this is the comparison we are doing at the last, that higher count is greater than lower count. If that's the case, if the number of higher is greater, if the number of lower is greater, will let Bob choose a number which is just exactly one uh, decremented from Alice's number, and will get all the lower count values since the number of lower points are greater than higher points, and else it means in here higher count is greater than lower count. So we'll choose a number higher than Alice's point. So in that case, since the higher numbers are greater in number than lower numbers, so we'll get all the higher numbers, and Bob will end up winning the match. And it is written in the question that we do not have to make sure that Bob wins all the matches. We have to make sure that Bob has a maximum percentage of winning all the matches. So let's check for the first test case if our code is working or not. So it is problem number 2169A. Yeah. So as I had said earlier, the the output is not fixed. As long as Bob is winning, our output should be correct. And in the first case, let's say as we have discussed, if we take 22, we'll get this point, all these 5 points since the higher count is greater. So we'll get all these 5 points and we'll win. And in the second case, if we take 499, we'll get it will be a tie anyway. We'll get anyone 3 points from here, and Alice will get 3 points from here. So it will be a tie. And in the third case, any number we can choose. It doesn't matter because Alice will still win. Yeah. So that's all in this question. That's all for this question. I hope you understood it well. So thank you.